Alright, let's find the derivative. Limit as h approaches 0 of f of x plus h, so that would be x plus h cubed minus f of x all over h. So again, Pascal's triangle is coming back into play, this time even more simplified because this is literally Pascal's triangle. So if you forgot Pascal's triangle, it's the 1, 1, 1, 1, 2, 1, then you add these together and then put the 1s on the outside. So x plus h cubed is going to have coefficients 1, 3, 3, 1. And then the x's are going to decrease from powers of 3 down, and the h's are going to increase from the right of powers of 3 up. So limit as h approaches 0, 1, 3, 3, 1, cubed, squared, linear, gone, cubed, squared, linear, gone, minus x cubed all over h. So one of the big things that you'll see when I pass by your test is I'm very picky about the algebra. If you forgot your limits, you lost some points. If you forgot to show at every line it was divided by h, you lost some points. Because the algebra is important and being equal is important. What I write from line 1 to line 2 needs to be consistent and match. So goodbye x cubed. If you really like to cancel and you don't want to write out an extra line, you could take an h away from some of your terms at this time as well. So that would leave me with 3x squared plus 3xh plus h squared. Now, at this point, no issues with my denominator. Plug in h equals 0 for all h values, and I get 3x squared plus 3x times 0 plus 0 squared. So those all cancel. And I get that the derivative of x cubed is 3x squared. What that means is that the slope of the tangent at any number x could be plugged into 3x squared. Slope of the tangent at any number x could be plugged into 3x squared. Because this, by definition, represents the slope of the tan as we knew it. Correct? Differentiate. Find the derivative of f of x. So flowing into that notation, that would be like saying f prime of x equals the limit as h approaches 0 of x plus h squared minus 8x plus h plus 9 minus all of f of x, which was the original problem, all over h. Algebraically, these are massy. Neat handwriting.
It's literally not a possibility.
Flowing handwriting. Important. You'll watch me go line by line. Like, I will write equals limit as h approaches 0. Write out my next line. Equals limit as h, like, use paper. Whoa. If I can't follow your work, the AP people can't follow your work, and I really start to know how you think. When they grade your tests, they don't know how you think at all. Okay, x plus h squared is x plus x squared plus 2xh plus h squared. Distribute the 8 minus 8x minus 8h. That 8h is important. The negative flows in. Plus 9 minus x squared plus 8x minus 9 all over h. Carefully cancel and simplify. Goodbye x squared, goodbye x squared. Goodbye 8x, goodbye 8x. Goodbye 9, goodbye 9. Factor out an h and write down neatly everything that's left. 2x plus h minus 8 all over h. Cancel your h's. Equals limit as h approaches 0 of 2x plus h minus 8. Plug in 0 for h and you get 2x minus 8. Once you plug in 0 for h, the limit goes away. We're done. Yes? Did you do it on your own and you got it, so you're happy? It is. So as I said, like, be neat. Like, if you are messy, like, you get lost and you will lose it. Like, you'll miss an H, you'll add a negative, like, write it neatly, take your time. Go ahead.
Last time, if we were like just continuing our work, but because we're doing like the f prime of x, now we can just like write it straight down instead of like rewriting and drawing arrows. Okay.
You could still, like, even if you didn't want to write, like, equal signs, like, you could, at the very beginning, have done all arrows once again. But technically, line by line by line by line, they're all equal statements. But some people don't like the equal signs because they feel like if they. So, yes, I'm okay with either. I will write equal signs because I'm not a big fan of arrows.
Usually that's what I write, but I know the last one we had to write the arrow.
Because you were like nervous about goofing up like where it was. I would have taken equal signs.
You would have done okay.
I've told some messier. They're not really messy. You just can't write big sometimes. Like the messier, like when they like. And I think you did. You kind of drew me some arrows because you like went this way and then you like went back up.
I go
Yeah.
across
So like.
the space and then I
It
go
depends
back
on how much
and forth.
space I have, because
Right.
sometimes we go like this.
Yeah, so like that's why the arrows are good because like I just follow your arrows.
Yeah.
So like if
Just,
you
like,
can go
follow.
down with equal signs, perfectly good. So the only difference before to this is that that was in general. This is at a point. So it's just like before. If you find it at a point, use the x approaches a value. If you find it in general, you do the h approaches 0. F prime of 3. So all that's really changing is how we write this. F prime of 3 equals the limit as x approaches 3 of f of x, which is x squared minus 4x plus 4. And that these are more complicated. Like they're a little bit longer. Minus f of 3. So this is not minus f prime, it's minus f of 3. So that's 3 squared minus 4 times 3 plus 4. All over, this one's a little different now. It's x minus 3. So this is where you usually have to cancel some stuff and then factor. Limit as x approaches 3, x squared minus 4x plus 4 minus 9 plus 12 minus 4. So plus 4 minus 4 end up canceling, and then negative 9 plus 12 is positive 3 all over x minus 3. Still writing my limit, factoring my numerator. value. So what that means, f prime of 3, remember f prime of 3 represents the slope of the tangent. So what that means is the slope of the tangent line is 2. So the slope of the tangent line is 2 for f of x equals x squared minus 4x plus 4 at x equals 3. These ones are messier, and we need to do this because we, as a unit, our fractions weren't great on our limit stuff. There's just stuff. So f prime of 2 equals the limit as x approaches 2 of f of x. Sorry, I flipped my order. Minus f of 2 all over x minus 2. Okay, if you're finding a common denominator, this is really like the limit as x approaches 2 of 1 over x squared plus 1 minus 2 squared is 4, 4 plus 1 is 5. So what that means is that the left side is missing the 5 and the right side is missing the x squared plus 1. So this piece gets multiplied by 5 over 5. This piece gets multiplied by x plus 1 over x plus 1. You only have to multiply the numerators. For whatever reason, we were trying to on our test to do it to the denominators as well. Limit as x approaches 2 of 5 minus x squared plus 1 all over that new common denominator, which is 5x squared plus 1 all over x minus 2. Now I would look at my top and I'd say, okay, that's negative x squared, 5 minus 1 is plus 4. Ooh, what does that look like? That looks like a cubed up difference of squares, right? Because what's wrong? The negative x squared and the positive 4. But we know in math that we can take out a negative, turn it to a positive, and factor it out. In the meantime, I also hate writing fractions and fractions, so I'm going to multiply by the reciprocal of the denominator so I can get that up into my fraction at this time as well. 5 minus 1 is 4.
Oh, okay. Okay.
It's all good. It's all
I was
good.
writing it down and I saw it right to that.
I was like, I'm not, and I wasn't trying to be like sarcastic about it. I was like, no, like 5 minus 1 is 4. But I feel like it came out kind of sassy, and I was like, no, I didn't mean for it to sound sassy. Like, I really meant 5 minus 1. All right. I'm also kind of annoyed with that. It's, we are getting a little sassy. So pull out that negative 1, and then you know, and I'm running out of room, so I'm going to erase even though I hate doing that to you, that x squared minus 4 is really x minus 2, x plus 2. And then we know that that helps get rid of my problem here. Okay. So they cancel. And I told them, I still have like 3 problems left to break, but I wanted to finish this too. So you can do at least a couple of you. I recorded and posted so you do it. And I'm keeping your notes. Alright, so you get the limit as x approaches 2 of negative 1 x plus 2 over 5 x squared plus 1. So at this point I can just plug in my 2. So I have negative 1, 2 plus 2 over 5, 2 squared plus 1. 2 plus 2 is 4, so you get negative 4 2 squared is 4, 4 plus 1 is 5, 5 times 5 plus 25. I'm not giving you word problems tonight.